You know, when we think about scientific discovery, we often picture this slow, steady process. But what if I told you we're in the middle of a massive revolution? A revolution where artificial intelligence is basically supercharging the whole system, changing how we cure diseases, explore the universe, and tackle some of the biggest problems on our planet. Okay, let's dive into this.
And just a quick heads up, all the information in this explainer comes straight from Chapter 11 of the tutorial, Introduction to Artificial Intelligence, which is put out by Virtualization Options LLC.
This quote right here is the key to this whole conversation. AI isn't just another tool in the lab. Nope, it's an accelerator. It gives scientists the power to ask and get answers at a speed that, honestly, would have seemed like something out of a sci-fi movie just a few years ago. But how? How does it actually do that?
Well, the best way to think about it is that AI is giving every researcher a set of brand new superpowers. It's not about replacing their knowledge or their gut feelings, it's about amplifying them. It lets them do more, see more, and connect dots they never could have before.
It really all boils down to a few amazing capabilities. AI is incredible at spotting patterns we can't see, at creating virtual experiments, at automating all the boring stuff, and even at helping scientists dream up new ideas to test in the first place. So let's break down what each of these superpowers actually looks like.
First up, we've got pattern recognition. Now, imagine trying to find one specific, unique grain of sand on an enormous beach. That's kind of what scientists are up against with modern data. AI acts like X-ray vision for that data. It can sift through absolute mountains of information. We're talking genetic codes, telescope images, you name it, and find these tiny, subtle connections that a human researcher could search for their entire life and still miss.
Next up, simulation and modeling. This is basically like having a crystal ball for your experiments. Instead of spending months, sometimes millions of dollars, to physically test a new drug or a new material in a lab, scientists can just ask an AI to simulate it. This means they can run thousands of virtual experiments in just a few hours to see what might work before they even pick up a test tube. It's a huge game changer.
And maybe the most practical superpower of all is just plain automation. I mean, science involves a ton of grunt work, right? Processing data, crunching numbers, reading through thousands of old research papers. AI becomes this tireless research assistant that can handle all that repetitive, time-consuming work, which frees up the scientists to focus on what they're really great at, thinking creatively and solving the big-picture problems.
So these superpowers sound pretty cool in theory, but where are they actually making a difference? Let's take a look at how this is all playing out in some of the most important fields of research, and how it goes from the lab into our actual lives.
Let's start with a big one that affects every single one of us, our health. Creating a new medicine is traditionally a super long, incredibly expensive, and often frustrating process. So what if we could radically speed that up?
This is what's so incredible. AI is helping to turn drug discovery from a bit of a lottery into a really targeted science. And as you can see here, it's hitting the problem from every angle. It virtually screens millions of potential molecules to find promising candidates. Then it predicts how effective they might be. It can even help tailor treatments to a person's specific genetics and design smarter, faster clinical trials. It's a total overhaul of the old way of doing things.
And the impact, it's just staggering. Look at this number. We're talking about compressing a process that usually takes over a decade into just a matter of months in some cases. That's not just a small improvement. That's a fundamental shift in how we fight disease and how we can respond to future health crises.
Okay, so let's go from our personal health to the health of our planet. Climate change is one of the most complex puzzles we've ever faced. It generates this overwhelming flood of data from satellites, from ocean sensors, from weather stations all around the world.
AI is becoming an absolutely essential tool for making sense of it all. It can analyze satellite photos in real time to track things like deforestation or melting ice caps. It's helping us build much better models to predict extreme weather like hurricanes. And really importantly, it helps optimize our renewable energy grids to make them more efficient. So it's not just helping us understand the problem, it's helping us build the solutions.
Now let's shift our gaze from our world out to the cosmos. Here we face a totally different kind of challenge, just a mind-boggling amount of data. Our modern telescopes produce more information in a single night than a person could look through in 100 years. So, how do you find the needle in that cosmic haystack?
Yep, you guessed it, AI.
It's what sifts through all that telescope data to find brand new planets orbiting distant stars. It analyzes signals from giant particle accelerators, looking for hints of new physics. It helps us classify literally billions of galaxies to map out the entire universe. Many of these discoveries would just be impossible without it. They'd be lost forever in a sea of data.
Okay. Now, as exciting as all of this is, we have to pump the brakes for a second. It's so important to remember that AI is a tool. It's not a magic wand. And like any really powerful tool, it comes with its own challenges and its own risks that scientists have to be super careful about. You see, for every incredible power AI offers, there's a potential pitfall we have to watch out for. It's amazing at finding patterns, but it can't tell you if a pattern is a real cause and effect relationship or just a random coincidence. It can process all this data, but sometimes its reasoning is a black box, which makes it hard for us to check its work. This means human oversight and critical thinking are absolutely non-negotiable.
And these hurdles are really serious. I mean, think about it. If we don't know why an AI made a particular prediction, can we really trust it with something important? If another lab can't get the same result using the same AI-assisted method, is it even real science? And what if the AI is trained on old data that contains our own past biases? It might just end up confirming what we already think, instead of leading us to new discoveries.
All of this brings us to what might be the most important point of all. The future of science isn't about AI replacing scientists. Not at all. It's about creating a powerful new kind of partnership between them.
This quote from the source material just says it perfectly. The AI handles the heavy lifting, the computation, the data sifting, the thousands of simulations. And that frees up the human scientist to do what we humans do best. Ask weird, creative questions, use our judgment, and follow our intuition to guide the research. It's the combination of raw computational power and human curiosity that's so powerful.
So, as AI gets better and better, the real question becomes, what's next? With this incredible new accelerator in our hands, which of humanity's impossible problems might finally be within our grasp? Curing Alzheimer's? Finding a source of truly clean energy? The answers are out there, just waiting for us to discover them.